Another critical component of training these models is data. I call it data. Some people call it data. I'm not sure of the pronunciation there, but yeah, mine is data. So the are n- data sets are needed for any machine learning or any machine learning task to train a model. You need access to data, and the data that is used to train these GPT or BERT models is very, very large. It is very large, and it is diverse and comprehensive, to, comprising of billions of tokens, sometimes like billions of tokens, or billions of words, if I can call it that, before we get into tokens. So billions of words on different topics, Yeah, it's so diverse, including natural language, codes, computer codes, all of that. Very, very large. Well, it's estimated that this is what happened when they were training the GPT-3 model, that they used these data sets. They used what is the data sets called common crawl. So there's a common crawl data set. Common crawl is just it's a web crawl data, and this had billion 410 billion tokens. 410 billion tokens. I think the space that was needed to save this is like around, or that is needed. If you want, you can download Common Crawl dataset. Easy. Just go on Google Common Crawl dataset, download. You'll find it there, and find ways to download it. It said that this comprised 60% of the training in the proportion. So training dataset proportion. So Common Crawl made up 60% of that training data set for GPT-3. And then there is one called web text web text 2, which is also just web crawl data. This had 19 billion tokens, 19 billion tokens, and made up 22%. Then there is one called books 1, which is just internet based book corpus. There's lots of books in there, and this one at 12 billion tokens. And that was around 8%. And then there's books two, which was also internet based book corpus, which had 55, contributed 55 billion tokens, and also 8% proportion. The reason why it's 8%, I'll explain why. And then both 12 and 55 cannot both be 8%, but I'll explain why. And then Wikipedia, Wikipedia is the Wikipedia data said that they had 3 billion tokens. And this contributed 3% of the data. So there is a reason why these are not really tallying is because I think from Common Crawl they only used 300 billion tokens, I think. So they were quite selective. They didn't use, so these are the tokens that are in that data set, but they selected some and then filtered out. So the problem is they didn't release the data set for people to actually do some auditing. Some of these were just things that leaked and all of that, but we're not quite sure exactly. But we know this is the data set that they used. We're just not sure which tokens that they actually did. And a token is a unit of a word. So my name is Houston, right? So this could be one token, or it could be split into two tokens, where it's you and then there's the stone there. That could be one token. This could be token. But roughly estimating it, you can just consider a token as a word. If you just want to do some rough calculations, um, in the next chapter, in chapter 2, actually, we are going to, when we're talking about pre-processing the data and all of that, we're going to get into tokenization, how to convert, how we are going to convert a normal word like Houston into actual tokens. We're going to do that in an upcoming chapter. But when you're looking at this data set, it is very diverse and it is large, and it helps the model perform very well on diverse tasks, like language syntax, semantics, and other tasks that just need general knowledge. And when Meta then came out with its own types of models, right? Okay, let me just put this down. I think where I'm writing, it is not friendly there. Um, Meta then created llama models, and the first llama model they added on top of the regular ones. They added active research papers, 92 gigabytes of that, and they went on to Stack Exchange, and from Stack Exchange, they got computer code related questions and answers, and they got like 78 gigabytes of that, 78 gigabytes of that, and by that they trained them. These are pre-trained models, right? These are the pre-trained models. So after training with this large data set, we create the pre-trained model, which is also called the foundation model, right? Foundation foundation model. These foundation models, they are really versatile. They are good at they're good at doing text. You can then add functionality by fine tuning them. I think we have explained you can add functionality by fine tuning them. By fine tuning, getting to this stage of pre-training, it is expensive. I think you can see even just storing the data, that's like 500 gig or whatever it is, that's expensive. So getting to this stage of pre-train of a foundation model is quite expensive. I think GPT-3 is estimated to have cost 4.6 million dollars just to train it, and this is just on cloud credits when the GPUs were running. When the GPUs were running, cost around 4.6 million. Then GPT-4, I think the estimates were 100 million or something like that. Insane numbers. So but the advantage is there are many open source models, many open source foundation models you can find on Hugging Face. So if you have a particular use case where you need a model that you can fine tune, you can download an open source model from Hugging Face that has been pre-trained. An open source model like Llama 3 is a foundational model. You can download that one and then fine tune it and fine tune it. And when you're fine tuning, you fine tune for things like classification or whatever it is for your particular tasks. Whatever you want to do them. The advantage is this stage now of fine tuning, because the model already knows how to play around with text. It can generate text. It can do text completion. That has been solved in that foundation model. So when you're fine tuning, you will need a relatively smaller data set to do that, to then fine tune it. You're not going to need all that common crawl or whatever it is. It has already been used to create the foundation. Now to create your very bespoke, your Houston GPT, to create that Houston GPT, you will need a relatively small data set. And in this course, we're going to, it will not perform extremely well, but still, we're going to see how fine tuning can be done with very small data set. And that's what I wanted to emphasize in this part here, or build the foundation in this part. In the next part, we're probably going to dig a bit deeper, because what we're going to use in this course is a GPT model. We're going to use the GPT-2 model. That's the one that we are going to use. The reason for that is because OpenAI was kind enough to actually release the weights of the model. So we can download the weights, we can access the trained model, the foundation model, and all of that. Why would we need the weights? The reason why we would need the weights is because when you're getting some of these models here that are fine-tuned, that you will fine-tune, sometimes what you would do is you will download the weights from the open source, and then you have your model you have you have like a blank model here that is the same architecture as the model that you're getting. And when you get the weights, you just load the weights into the model. So here it will be a blank canvas. It is the same architecture as the model that you want. We are going to build the architecture of a GPT-2 model. But because it is blank, it has not been trained at all. When we build it from scratch, it hasn't gone through pre-training. And if we are to pre-train it, it's going to take us lots of money and lots of time and all of that. What we can do is we can just download the weights that OpenAI released and load them into our architecture, and then now we'll have a pre-trained GPT-2 model, and we are going to do that. We have a pre-trained GPT-2 model that we are going to then fine tune. Then we are going to fine tune. So in the next video, we are going to take a look. We're going to introduce the architecture of a GPT. Let's understand it better before we get into chapters where we are going to actually see the codes and play around with them. So I'll see you in the next video.